Hey everyone, welcome back to another video session by Simplilearn. In this session, we will learn about C++ polymorphism. So let's go ahead and have a look at what we'll be covering today. So we'll start with what is polymorphism in C++, then types of polymorphism in C++, that is compile time and runtime. We'll also study function overloading and operator overloading under compile time polymorphism. And under runtime polymorphism, we will learn about function overriding and virtual function in C++. But before we begin, make sure to subscribe to our channel and press the bell icon to never miss an update from Simplilearn. So what is polymorphism in C++? Polymorphism is an important topic of C++ OOPS concept. The word polymorphism is derived from two words, that is poly, which means many, and morphs, which means forms. So basically it means many forms. Polymorphism in C++ can be defined as when the member function or the object behaves differently in different situations or circumstances. Then it can be called as polymorphism. For example, a mother has different relationships with different family members inside the house. For example, she is a parent to her child, she is a wife to her husband, she is a sister to her brother, and she is also a daughter to her parents. So we can say a mother as a single entity has different behavior among different members. And same goes for polymorphism, where functions behave differently in different situations. Now let's understand the types of polymorphism. There are two types of polymorphism in C++, that is compile time polymorphism and runtime polymorphism. So let's start with compile time polymorphism. As the name suggests, this type of polymorphism occurs during the compile time and it is achieved by overloading the function or overloading the operator, that is by function overloading or operator overloading. So what is this function overloading? Function overloading is a feature in C++ where the functions having the same name but different in terms of parameters or type of parameters can be overloaded. For example, as we can see, two functions with same name func differ in the type of arguments. One data type is double, another data type is integer. So when we make a call to the function with arguments of type double, it will invoke the suitable function, and the same goes for the other one. In example 2, there is a difference in number of parameters among functions. So while calling the function, if we pass two arguments, it will invoke the first function, and if we will pass three arguments, then it will invoke the second function. Then next is operator overloading. Like functions, operators can also be overloaded. In operator overloading, we can redefine the functionality of the operator. It helps us in redefining the already existing operator. For example, instead of writing sum equals s1.add s2, we can easily write sum equals s1 plus s2. That is, we can redefine the plus operator and use it to add the numbers in the operator function. And we will discuss the syntax of operator overloading in the examples. Now coming to runtime polymorphism. In this type of polymorphism, the functions are invoked during the execution of program, that is during runtime. This runtime polymorphism can be achieved through function overriding. So let's understand this function overriding. In function overriding, the function of the base class gets a new definition in the derived class. In this, more than one function has the same name and same type of parameters. The only difference is in the definition of both the functions. That is, functions have different definitions in the parent class and the child class. As you can see in the example, void message function has a different definition in the parent class and in the child class. Both have the same name, but in parent class it is printing hello there, and in child class it is printing nice to meet you. by using the object of the base class or derived class, we can invoke the suitable function. So let's move on to our next topic, that is virtual function. Virtual function is also used to achieve runtime polymorphism. It is a function that is defined in the base class and then is redefined in the derived class. The function is defined using the word virtual in the base class, and the name of the function is same as that of the derived class, having different definitions as shown. It tells the compiler to perform the late binding on the function in derived class. The function call is resolved at runtime and in late binding, and the compiler determines the object type at runtime. With the help of virtual function, we can invoke the derived version of the function in the derived class. So as we have covered the theoretical aspect of C++ polymorphism, so let's go ahead and cover the practical aspect of this topic in our code editor, that is VS Code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So here we will make a new file and let's name it as poly1.cpp. Alright, poly1.cpp. So let's save it. So here we will do an example of function overloading, which is used to achieve compile time polymorphism. And we know function overloading is a feature in C++ in which two functions have same name but differ in terms of parameters or number of parameters, or the type of parameters can be overloaded. So let's start. First of all, we'll write the header file #include iostream. Now using namespace standard. Alright, so now we will create a class king, and inside that class we'll do the overloading. So the class name is king, and inside the class, first of all, let's make public scope. Now we'll create a function. Return type is void and the name of the function would be pro. Inside this function, let's say we are passing two arguments, int a and b. Alright, now we'll print both of these arguments or variables inside this function. Alright, and we'll use endl in the end. Okay, after that we'll create another function, and the name of the function is same, that is pro, but in this case we'll make the arguments like int a, int b, int c, int d, and int e. So there are 5 arguments in this function, second function pro. As we know that the name of the function is same, and now inside this function we'll simply add all of these. So a plus b plus c plus d plus e. Alright, once we are done with this, we'll use semicolon in the end of the class. Alright, now we'll start with the main function. Inside the main function, we will create the object of king class, king, and the object would be k. With the help of this object k, we will call these functions. As we know, the name of the functions are same, the only difference is in the number of arguments. So I'll call the pro function, which accepts only 2 arguments. So the first pro function will be invoked. So I'll pass 10 and 20. So these 2 arguments will be passed over here. Alright, similarly, now we'll call the pro function again, but now we'll pass 5 arguments so that the second pro function would be invoked. So let's say I'm passing 12, 23, 20 and 62, 6. These are some random numbers. Alright, now return 0 in the end. Now let's try to run this. I think we are done with this. First of all, let's save it, and now let's try to run this. So this is our output, 10, 20. Let's multiply both of them. It will look good. Let's save it and run it again. As you can see, 200 and 123. So this is our output. 10 into 20 would become 200, and if we add all of these, we'll get 123. So this is our correct output. So this was the example of function overloading, and let's start with another example. So now let's create a new file and name this file as poly2.cpp. Alright, we have saved it. Now here we will do an example of operator overloading. As we know that in operator overloading we give definition to already existing operators, or we can say we can redefine the functionality of already existing operators. So let's start. First of all, we'll include the header files as we have done previously. Hash include iostream, then the namespace standard. So first of all, we'll start with the main function, and inside the main function we will write the name of the class that we will create and the object. Let's say the name of the object is O1, and we'll pass the arguments to the constructor. Let's say the argument is 6 and 8. Alright, then I think we can write return 0, and we'll do the rest afterwards. First of all, we will create the class. So as we know that the name of the class is overload, so let's create it, class overload. And inside this class, inside the private scope, we'll start with the variables. Let's say the first variable is n1, and let's declare another variable n2. Then we will create the public scope. Inside this we will create the parameterized constructor, so it is of same name as that of the class, that is overload. And now as the constructor is parameterized, so int num1 and num2 are the parameters. So when we'll create this object O1 and we'll pass these arguments, so it will go here. And alright, inside this, in the definition of this constructor, we will declare the variable res, and we will assign num to n1, we'll assign num2 to n2, and let's say we'll do the subtraction. Alright, n1 minus n2. Alright, now we will display the result, that is res. So res, and then the variable res. After that we'll use endl. Alright, so once we are done with this parameterized constructor, then we will create a operator function. So void is the return type, then we will write operator keyword. This is the syntax of operator function. Then after writing the keyword, we'll write the symbol. Let's say minus is the symbol. Then the arguments, if there are any arguments, then we can put those. Then inside the function, that is in the definition, we can perform whatever the functionality we want to perform. So let's say in this case we'll just make the numbers negative, so we'll do that. Alright, now we'll do the calling part of this. We'll simply use the symbol and the operator, and this is how we'll call the operator function. This is very simple, and after that we have to display the digits as well, as we have made them negative in this part. So we'll create a function display, and inside this function we will display those digits or numbers. So we'll write n1 alright. After this we'll do same for n2, so we'll write n2, then there is ndl in the end. Alright, so here we are displaying this. So once we are done with this, the class is finished, so we can use the semicolon in the end. And we have to call this void function as well, so we will write o1.display, o1.display. Alright, we are done. Let's see whether it works or not. Let's save it and check it. So as we can see, the result is -2, that is 6 minus 8 equals -2, that is correct, and n1 is -6 and n2 is -8 because we have made them negative inside this operator function. We forgot to add some space in n2 and n1, so that is why it is looking like this, but the answer is correct, and this is how we can do the operator overloading. In this part we have used the return type, then the operator keyword, then the symbol, and if there are any arguments then we can pass those arguments, and if there are not we can put it like this. So this is our example of operator overloading. Let's do another example. So now we'll do an example of function overriding. So let's name this poly3.cpp. So in function overriding, the function of base class gets a new definition in the child class, and when we call the function of the child class using the object of child class, then the function of base class gets overridden. So now let's do the example of this function overriding. I think we have named it wrong. poly3.cpp. Alright, let's name it 4. poly4.cpp. Alright, now let's save it. Now include the header files. Using namespace standard. Now we'll start with the class parent. So this is the base class and we have named it parent. Inside the parent class we will create a function. For that we'll create the public scope. Inside the public scope we will create the function print, and we will display the message, this is the function of parent class or base class whatsoever. Alright, so this is class parent and semicolon in the end of the class. Now we'll create the child class, child derived from parent class. Name of the class is parent. Similarly we'll do the public scope and create the function void print. So it is same function as that of the above class, and inside this function we will display this is the function of child class, derived class, let's say. Alright, once we are done with this, semicolon in the end and semicolon in the end of the class as well. Then we can create a main function, and inside the main function we will create the object of child class, child obj. So as we have created the object of child class or derived class, so with the help of this we will override the function of the base class. So we'll write obj dot print, which is the name of the function. So as we have created the object of child class, so it will call the derived class or child class function, and in the end let's say return 0. Now save it and try to run this. This is the function of derived class. So as we have expected, so it is calling the child class function. So this function of the parent class gets overridden as we have used the object of child class and call this function print, which is of same name. So this function which is in the child class gets to print derived class. So this is our output. So now let's do an example of virtual function in C++. Virtual functions are defined in the base class to ensure that the functions gets overridden, and when we use the base class pointer to hold the derived class object or the child class object, the base class pointer will always call the base version of the function and not the derived version. So to solve this problem we use the virtual keyword in C++. So now let's start with it. First of all we'll write hash include iostream. Now the namespace standard. Now we will create the base class base, and then we'll use the public scope. Inside the public scope we will create the virtual function. We'll use the virtual, the return type, then the name of the function, that is print. And we have created this virtual function inside the base class. Now we'll print. This is the function inside the base class as we have done previously in the previous question. This function, this is the function of base class. Yeah, it would be right. Alright, once we are done with this, we'll close the class by using semicolon. Now we'll create the derived class and we'll name it derived from the base class, whose name is base itself. Now here we will use the public scope and we'll create the function of derived class, print function, and we'll print this is the function of derived class. Alright, now we'll use the semicolon to end the class. Now inside the int function, int main function, first of all we will create the pointer of base class, base dereference operator b. So we have created the pointer of base class. Now we will create the object of derived class, derived d. So now we will store the address of derived class object to the pointer of base class. So let's do that. B, which is a pointer of base class, address of operator, the object of derived class. So now we will call the print function using the pointer of base class, and it will print the derived class function because the pointer of base class which we are using to call the functions points to the derived class object. So now let's do the calling part. All we need to do is the pointer and the arrow operator and the name of the function, that is print. After that we can write return 0. Now everything is done. Let's save this and run it. As we can see, this is the function of derived class. Here we can see. So the derived class function is getting called, which we wanted. So this is an example of virtual function in C++. We have used this virtual keyword over here, and using the base class pointer we have called this function, and these were some examples of different topics in polymorphism in C++. You can try some more examples on these topics. It will help you in understanding this topic in a better way. Alright, with that we have come to the end of this video. If you like this video, please give it a thumbs up. I hope it really helped you all. Thanks for watching, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.